Hi everyone, very nice to be here and very nice to see like such a big crowd. And again, it's a pleasure to be here. And I see a couple of people pointing Voyager, Voyager. I'm going to explain to you what Voyager is in a bit. Right. Okay. I'm going to clear there. A couple of highs. Hi everyone, my name is Chi Chuan or Chi Chuan Ang. I'm from Malaysia and I'm making I took a 1 hour flight over to Singapore and this is a fantastic crowd. I'm so happy to see all of you here. I am a developer at Nethermind. And Nethermind does a couple of things in the ecosystem, in the Web3 ecosystem, and one of them is building Explorer for Starknet. And the name of the Explorer is called Voyager. So this is a quick explanation of what Voyager is. It has no relation to do with the exchange, right? I'm not going to talk about, where's my clicker? I'm not going to talk about all the other products that we built because today the topic is going to be very specific on Voyager. So, yes, I'm a developer at Voyager Nethermind. Okay, this is my PFP. Yeah, cool. Next. Oh, what I do? Oh shit, what I do? How do I go next? Do I click? Okay. First up, I would like to introduce a couple of building blocks in a blockchain, right? A blockchain typically consists of blocks. You don't say because blocks chain and block. And within a block, we have transactions. And transactions are typically interaction to a contract, and contract have functions. And whenever there's a state change, whenever your contract wants to have a state change, normally the contract does to emit an event. And in the case of an L2, typically you have messages. So these are what I call the basic building blocks of blockchain, and the same is true for Starknet. And these are the typical things that people are interested in when people want to understand or want to know about the state, about the information, about the data, or whatever you want in the blockchain. So these are the things that are important to you, right? So what do we normally use blockchain for? So I'm giving a simple use case, right? The first thing that you would normally do is that after I send funds to probably him over there, the first thing that I want to know is that I want to know if my transaction is successful or not. So in Starknet, there is a concept of received on L2 and received accepted on L2 and accepted on L1. And in Voyager, I clearly have a small screenshot that describes this, that shows that we have this status. So after making a transaction, you're able to accurately see the status of the current transaction you're making, whether or not it has been finalized on L1 or it has been accepted on L2 and whatnot. The next thing that people are generally very interested in is to understand like how much are being transferred. For example, if I send ETH from A to B, I would like to know how much am I receiving or how much am I sending accurately. So the first thing that we do is that we normally type in we don't type in, we copy and paste the transaction hash to a block explorer, in this case the Voyager for Starknet, and we will see like, okay, if the value is correct or not, if I'm sending the right amount of ETH. I normally do that when I try to, withdraw for an exchange. I want to make sure that exchange is not making any bucks. The first thing I do is I copy and paste the transaction hash to a block explorer of interest, and I'll check the value is correct. So these are basic functions that block explorer should have, and that Voyager has it. And finally, who is sending me money, or who am I sending money to? So the from and to parameters are super important. And these are the couple of basic things that, of course, a block should have, and we are, of course, highlighting them. Okay, cool. I would like to bring you to a world of the ancient world, where life it's not as good as now, and life is without block explorers. My goal is to show you, is to try to attempt to let you know that we are taking block explorers for granted. So here it goes. So to understand how a transaction looks like without Explorer, right now we take Explorer for granted. We look at the nice UI, everything is nicely popped to us, it's nicely described to us. Without having Explorer, what we will need to do is that we will normally need to call the JSON RPC endpoint, and this is an example of one by calling get transaction receipt, passing in the hash as the parameter. This is the thing that we are going to get returned with. So as you can see, many of these are the hacks, like the contract address is hacks. The core data it's basically the thing that you're calling the parameters that you're calling a contract. They are also in hacks and not too human readable. What I'm trying to make a point here is that it is not too clear, not easy for human to instantly understand, right? Sure, you can slowly copy and paste and decode this data, but sometimes if you are doing it, how can I say, you want to do it many times, you want to be fast, doing it manually may not be something that you would like to do, right? And now, for example, I'm calling a contract in the previous transaction, so I want to understand what the contract is doing, right? So there's another RPC endpoint on Starknet, it's called getClassAdd. It will return me the ABI and bytecodes, and the constructor and bytecodes or whatever. So these ABIs are, how to say, templates for your contracts. So they have read-write function, but they do not contain the logic. So you only know like what function exists, what parameters you have to pass in the function, but you do not know exactly what the function does. So to do that in the Block Explorer, we urge people, Cairo devs, to verify his or her contract on Explorer. So we will save the code for you, and users will not need to guess what the contract is doing. Users will only need to read the code to understand the logic of the Cairo contract they are interacting. So this exhibits the, how can I say, transparentness and permissionless attribute of a blockchain, of a public blockchain. As you can see, as we are trying to understand how a transaction is, what a transaction is doing, what a contract is doing, it is non-trivial already. Now imagine if you want to do something a bit more complex. For example, if I want to understand an ERC20 token, or if I want to analyze DeFi protocols. For example, if I want to plot charts, like what is the TVL over time for this LP pool. Imagine you have to do that using RPC calls. I'm pretty sure you will not be happy. Your mouse will not be happy, and your doctor, your psychology, whatever, will not be happy. Your mental doctor will be happy. It's not good for sanity. So do not do that. And before I move on to the world of explorers, I would like to explain the motivation behind why Nethermind is building an explorer for Starknet. So being an early supporter of Starknet, Tomasz, our CEO here, huge supporter of Starknet, and a personal believer of Starknet, we decide that we know that we understand the importance of Explorer in an ecosystem. And at the point of time, there weren't any team that was building Explorer for Starknet. So Nethermind decided to take up the mantle to say that, hey, Explorer is very important and we will build one for this ecosystem. So it remains to today that Voyager is one of the explorers for Starknet. And because Starknet is different, it's non-EVM, that means that Starknet we're not able to reuse some of the EVM explorers such as Etherscan, such as Block Scout, because they are fundamentally different because of the Cairo length. Versus EVM, they are not the same. So there is a need for someone to take up the responsibility to build Explorer. And therefore, Nethermind decides to build Voyager. So let's move on to the world with Block Explorer. It will look like this, very futuristic, very easy, everything's convenient, right? At a how can I say, flick of your thumb. And I include this very cute photo. Let's explore with Voyager. Okay, so let's look at a sample transaction of in Voyager. How does it look like? So first up, I would like to stress. Okay, so first up, this is how it looks like on Voyager. I took a screenshot of this transaction. It's not too important. I will slowly highlight the elements that are important for you. Okay, you can take a photo, but it's not too important, but you can. The first thing that you probably notice is that we have give some contract a name. So unlike in the transaction receipt, where everything is a hash, Voyager takes up the responsibility in naming the contract address. So this one could be 0x something. To know that, you have to just hover it over to see the original contract address. But over here, for human readability and simplicity, we rename the contract to be SIP-swap. So right off the bat, you know that, hey, this transaction has something to do with a SIP-swap swap. And you know that this is has something to do with the if USDC, because we also label, we also give this pool address a name. So name tagging is something that's very important in the Block Explorer, because it helps in the UX user experience. So using it, you don't need to remember. Oh, okay, 0xABC stands for X contract, 0xBCD stands for Y contract. We explorers, we save it on our DB, we give it to you, we help makes your life easier. And of course, it also shows how much token is being transferred. So right off the bat, you're able to clearly kind of understand, like, okay, this transaction is making a swap of how much USD to gain how much ETH at certain point of time, so on and so forth. So yeah, as compared to your RPC, this is I think it's much better. Of course, we also have some other things, such as we say when is the swap happening. Well, normally people don't care about when, but for example, if you are someone who wants to have a report your income on tax or something like that, the timestamp could be something important. And we also highlight who is interacting with the protocol. Oh, a quick highlight that this is the status that I mentioned before. Like over here, you can see that it's currently being accepted on L2, and after waiting for a couple of hours, it will eventually get finalized on L1. And if you were to scroll down for a bit, for those who would like to understand what the transaction is actually going through, we show the function that is being made in the transaction. So spoiler alert, Starknet is native account abstraction, and it supports multi-call by default. So this transaction performs multiple function calls right off the box. So the first transaction will be the first function call will be approved. So we understand in the world of Uniswap in Ethereum, you first have to approve a token that so that the protocol can spend your token. So this is the first step that is going through now. SysSwap is using a similar method as Uniswap, and you can see that we are approving the ETH token. And who is the spender? This is the spender. And this is the amount. And I know hex is something that is not something that we humans are familiar with. So if you were to click on the tab, the decimal tab, you're able to see in a decimal form. So that probably could be something that is very helpful for you. And again, this is a multi-call. So after you approve, you definitely want to perform a swap, because that's why you approve in the first place, right? So again, we show by having the protocol itself has a nice name that sort of explicitly describes what it's doing. It's called swap exact token for token supporting fee on transfer token. So it means that you are swapping, USDC to ETH with some fee. Yeah, so this is what the function is doing. I did not look in the code, but from the name, you can sort of imply, right, what this function is going to do. And again, these are the details in the input parameter. So again, I stress that, hang on, where was I? I stress that for those who are not good in hexadecimal like me, decimal is something that's already available. So you can see that you are swapping in this much of USDC, and you're getting this much of ETH. Right? And for those who are really into swaps and knows like how does a liquidity pool works, you will specify the routes. So basically these are like the number of hops you take for a swap to occur. In this case, it's only one route, and this is the pool that is involved. So that was pretty much what happens in the transaction. You're able to understand how much is being transferred. You're able to understand who you are interacting with. If you want to know more, you are able to understand the function that's being called in the transaction. Something that could be interesting to you, for those who really want to understand the state changes, you may want to visit the Events tab, and this is how Voyager lists the events out. Events are basically emitted when a contract has state updates. It's not a must, but it's a good practice to do it. It helps in some DEX to write indexes. And it also helps for users to sort of understand what is going on in a pool, for example. I'm not going to describe each function, but I'm going to let you see that, again, the name here is being described, so you kind of know that when a swap has happened, you know that some transfer event has occurred, some transaction has been executed, there's some swap-related events, and some token transferring events. So this requires a bit more of a specific protocol knowledge. So you kind of need to know SIP swap to understand what is actually going on behind the scenes. So let's look at a swap contract. If I were to click in the swap address that I'm interacting with, immediately I will reach this page. This is a contract page. And the two things that I would like to highlight is the type, which Voyager has labeled as ERC20. To do that manually, you need to look at the ABI, understand that ERC20 will need a certain type of function, and classify it manually. But Voyager itself takes all the ABI, classify it, and store it in our DB. So at the moment you visit this page, we already know that it's ERC20, or ERC1155, or ERC721. So that means that this contract will definitely have some sort of like fungible token. And in the world of Starknet, the logic of the code is being is being represented by a class. So for those who are interested, this is a class hash. You may click on it to look more detail as to who uses the logic of this class, and who or what the ABI of the class looks like. And there are multiple tabs that I do not want to talk about today because there are so many tabs. But I would like to highlight some key tabs, such as we have the code tab that shows the contract ABI. And if this contract is verified, the contract code will be displayed here. So you're able to examine the logic of this pool from Voyager only if the contract is being verified. And of course, for people who want to interact with the contract very fast without having to write code, you may easily interact with the contract via Voyager. The read and write tab is here, and you're able to call your functions here. So, okay, the alternative to doing that is to write your own code. Use Starknet.js or Starknet RS, depending on the language that you like. And then you connect to your wallet, and then you write some code to like, interact with the contract of interest. If you want to be quick, the Explorer is the way to do it. Click, 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 interact, and transaction send. I mentioned messaging. Messaging is something that is unique to layer 2s, and Starknet is a layer 2. Messaging means that the information that's been transferred from layer 1 or layer 2 to layer 2, or layer 2 to layer 1 via an official bridge. So the common messages that was used is to bridge transaction. So for example, if you would like to transfer ETH from mainnet to Starknet, you rely on messages, the messages on Starknet, to receive your funds on Starknet. And the reverse is true. Should you want to withdraw, you call an L2 to L1 message, and the mainnet will then receive that, hey, I received the message, everything checks out. You're then able to withdraw your funds from layer 1, which in this case, mainnet. So we have a dedicated page for this. Also, name tags to show what are the contracts that are being involved in this message, and also the direction. So L2 to L1 from Stargate to whatever contract will typically mean that you are withdrawing funds from L1. So that means you are transferring from L2 to L1, and then you are taking it out on mainnet. The reverse is true. And if you were to wish to understand more about how the details of messages, you click into the hash, and this is how you look like. The payload, we have the payload, which is the message that's being sent, and this is very contract specific. It depends on the L1 contract or L2 or the L2 contract, depending on the direction that you are interacting with. So this one requires a bit of a, how can I say, a bit of a tedious work to understand what payload means. And finally, again, I stress that the message that we look at was a withdrawal message, and therefore Voyager knows that it's a bridge transaction and has nicely highlight that this is a bridge transaction. So we have the L1, L2 address that was involved, the if that has been withdrawn, and when was it withdrawn. So for those who would like to understand a bit more about the network status or the transaction fee or whatever, we have a couple of tabs here. We do have charts. So charts are a good way for us to visualize as to how the network's doing, or how the whatever that is involved. So I would encourage everyone to visit our analytics tab. This is an example that this is one of the examples of our charts. And for those who find it useful, thank you. For those who like to have more charts, you feel that I would like to see this chart in Explorer. we are very, very happy to listen to you and also to write more charts. Because the idea is that should you want the chart, I'm pretty sure there are a lot more people who will need that chart. So it will be very, very beneficial for us to build a chart for you, not only because it helps the community, it also Voyager will also be, how can I say, be more helpful for you guys. And so all these are kind of manual, right? We talk about RPC, those are very manual. Exploring the Explorer is less manual, but I still say it's manual. So the question is, why do it manually when we have an API beta release? So I would like to stress that our API beta release is out now. We have a documentation for those who are interested. How do you apply for an early release? You just need to scan this QR code, or you go to voyager.online and there's a top banner where there's a link and you click onto it and you have a Google form. So from there, you request your access and we'll give you an access ASAP. Of course, the API is in beta release, so things might change, things might break, but we definitely value your feedback. Okay, a couple of people still scanning. Okay, we are good. And finally, I would like to thank everyone for listening, and I hope you enjoy. And any questions from the floor? Thank you. Any questions about Explorer? Oh, yes, this one.
So what is the challenge when you build an Explorer for Starknet versus traditional Explorer?
Okay, thank you for the question. The question was, what was the challenge when building an Explorer on Starknet versus building Explorers on, for example, EVM chains, right? So that is a good question. A bit of a background for myself. I used to work at Etherscan, so I've been building Explorers for both ends. So I think I'm qualified to answer the question. So one of the main differences I face when building Explorer for Starknet is the rapid changes of the protocol. So for example, for class, the concept of class did not exist before. So when they introduce the concept of class and there's the logics in the class, we kind of need to redo our architecture to accommodate for that, and fast, because Starknet moves too fast. So we have to do it within like a couple of weeks to make sure that Voyager does not break. That's one of the challenges that we face. The second challenges is that there are L2 specific stuff or Starknet specific stuff, such as messages, that are definitely not present on an L1. So we need to always think as to how users may need the data, or how this data can be displayed in a way that's beneficial for users to come up with a page and UX. Of course, things are not perfect. We value feedback, but we always try to dog feed our own product and try to see that, hey, this is not good enough or this is good enough, so on and so forth. The third one, the native is kind of like a good point of Starknet, but it's kind of like a different thing on Starknet as well. We have the native account abstraction. For those who are not familiar with, it means that all contracts are accounts, right? In the world of EVMs, they are all EOAs. So one transaction can only call one function. But in this case, it's multi-call by default, depending on the account they're using. So we need to kind of redesign the way to show the users, to highlight that the difference between the Etherscan you're used to and the Starknet Explorer that you are now using. So the challenges, TLDR, I said a lot. Protocol changes, Starknet specific features, and Starknet specific features, and multi-call, which is and UIs that we need to think as to how we cater for the users. Hope that explains. Thank you. Another question here. The question was, what are the missing features compared to Etherscan? I have to admit that Etherscan is very much mature. They have been in the market for more than 5 years. 5 years or so. Voyager is a very new Explorer, because Starknet is new, right? We have been here for I think 1 or 2 years. Missing features. They do support a lot of DEX-related data. So there's a DEX tool where you click on it, it can view all Uniswap v2 and v3 data. That was built by me. Before I left. That is missing. There's a token approval tab, which was a bit not missing. But these are the features that we hope to one day bridge. We definitely want to prioritize them, but we do have other backlogs which are more urgent, like protocol changes is one of them. So these are the features. There are definitely a lot. If you were to scroll down, like definitely a lot, such as the ability to lock in, the ability to private name tag, the ability to verify contracts. There's a lot. There's a lot to play with. So, but our goal is to bridge the features with Etherscan as close as possible, or even to have more features than Etherscan, because Starknet has Starknet specific features. Yeah, that's our goal. Hope that explains. Oh, we have one more over here.
In terms of coverage of developers uploading stuff, uploading like contracts into Voyager, how does that compare to, like proportionally, how does that compare to what's in Etherscan?
So the contract's more. So the question was more about contract verification. How does it compare to Etherscan? That's a very good question, to be honest. Etherscan supports Solidity and Viper verification, and Viper Solidity verification are kind of stable. Things haven't changed that much. But for Cairo, there's a Cairo 0, there's a Cairo 1, there's a Cairo 2. I know I was told to drop the Cairo 1 and 2 thing, but I still say it. Sorry, Starkware. Okay, this is a problem for us because Cairo 0 was written in Python, and Cairo 1 onwards is written in Rust. So we kind of have to maintain two kind of compilers. The concept's always similar. You get the contract from the user, you compile it on your end, and you compare the bytecodes that has been submitted on chain. The difference is the number of compilers that we have to maintain. So in Cairo, there's always like a one compiler release every week or so, I reckon. So every 2 weeks, yeah, that's an expert here. So the maintenance is much higher, and which is why our Cairo 1 verifier is still in progress, because we kind of finished that already, but then there's a breaking release in Scarp, so we kind of need to redo that part. So yeah, those are the challenges that we face. Thank you for the question. Any more? Don't be shy. You don't get to talk to people who work in both Explorers every day. Okay, I believe I'm clear, and thank you so much for your time and your attention. I hope you enjoyed the talk, and I hope you learned something. Thank you.